On this 6.7 Power Stroke Superduty P0401 may be an EGR flow code. In plain terms, the PCM may be seeing less EGR flow than it expects during the monitor. The truck may run with reduced power or a derate message, and after the repair, that message may not disappear instantly. Broadly, this can involve airflow measurement, intake or exhaust restrictions, EGR valve control and feedback, wiring or connector problems, or the EGR cooler bypass and its vacuum controls. Treat this as a technician-level electrical and functional diagnosis. Before chasing P0401, start with the basic system checks. If other MAF, intake air, exhaust system, or VREF-related codes are present, handle what those codes mean first. Also remember that regeneration can skew the values you are watching. If regeneration starts during testing, let it finish before continuing. And not every PID is available on every truck, so confirm your scan tool can display and command what this path needs. Confirm the codes that are actually present and let the code mix choose the branch. On a P0401 path, the cooler bypass solenoid power and control circuit checks are not always the first move. But if the code mix points to the bypass solenoid circuit side, start there before moving into the mechanical and vacuum checks. With the ignition off, disconnect the EGR cooler bypass valve solenoid connector. Turn the ignition on and measure voltage at C1622 pin 1. You are looking for voltage greater than 10.5 volts. Then, with the ignition off, disconnect PCME and check resistance between C1622 pin 2 and C1232E pin 64. The resistance should be less than 5 ohms. Next, check C1622 pin 2 for a short to ground. Resistance should be greater than 10,000 ohms. With the ignition on, check C1622 pin 2 for a short to voltage. Any voltage present points to a short to voltage concern. Finally, with the ignition off, measure the solenoid on the component side between C1622 pin 1 and C1622 pin 2. That solenoid resistance should be between 10 ohms and 40 ohms. Any failed circuit result gets repaired before you continue. Then clear the PCM codes and repeat the self-test. If the circuit branch passes, or if the P0401 path routes you straight into the bypass system checks, visually inspect for damaged or leaking vacuum lines, a damaged bypass valve actuator or linkage, and a damaged bypass valve solenoid. Manually move the actuator and check for sticking or binding. Some inconsistent movement can be normal, so do not condemn it just for that. If you find a real concern, repair it, clear the PCM codes, and repeat the self-test. If not, check whether the cooling system is overheating or low on coolant. If it is, repair that condition first, then clear the codes and retest. With the ignition off, observe the EGR cooler bypass valve linkage. Ignition off should leave the linkage fully extended. Start the engine and watch the linkage. It should move from fully extended to fully retracted within 6 seconds. If the linkage is always retracted, or if it does move as described, continue by checking for a stuck-open bypass valve solenoid. With the ignition off, disconnect the EGR cooler bypass valve solenoid connector. Start the engine and watch the linkage. The bypass valve is normally closed with the engine off or when commanded to 0% duty cycle. And when it is closed, EGR flow is directed through the EGR cooler. If the linkage is fully retracted during this check, the supported direction is to install a new EGR cooler bypass valve solenoid, clear the PCM codes, and repeat the self-test. If it is not fully retracted, move to the commanded functional test. For the functional test, verify EOT is greater than 60 degrees Celsius, 140 degrees Fahrenheit. Connect the bypass solenoid, start the engine, and monitor EOT and EGRTC. Command VGTDC to 60%. Raise RPM DSD to approximately 1500 RPM. Command TP-DSD to 0%. Command EGR-VPDES to approximately 60%. Then command EGR-CBV to 100%. Wait 5 seconds, command EGR-CBV to 0%, and watch MAF and EGRTC. On this Super Duty pickup, the passing result is a MAF increase by less than 0.014 kilograms per second, 14 grams per second, and an EGRTC decrease by more than 28 degrees Celsius, 50 degrees Fahrenheit. If it passes, the system is operating correctly at that time. If it does not pass, inspect the EGR cooler bypass valve and EGR cooler core. Repair is necessary. Clear the PCM codes and repeat the self-test. If the earlier linkage behavior points you toward a vacuum problem, disconnect the EGR cooler bypass valve actuator vacuum hose and connect DSL-ENG pressure test kit 014-0761 or equivalent to that hose. Start the engine. You should have 78 kPa, 23 nhg, or greater vacuum at the actuator hose. If that vacuum is present, the supported direction is to install a new EGR cooler bypass valve actuator. Clear the PCM codes and repeat the self-test. If it is not present, move upstream. Disconnect the EGR cooler bypass solenoid vacuum hose from the solenoid. Connect the same pressure test kit to that hose and start the engine. You should have 67.73 kPa, 20 nhg, or greater vacuum at the bypass solenoid vacuum hose. If that vacuum is present, the supported direction is to install a new EGR cooler bypass valve solenoid. If it is not present, diagnose the loss of vacuum by checking hoses for leaks or restrictions and checking vacuum pump operation. Then repair as necessary. Clear the codes and repeat the self-test. If the bypass solenoid circuit branch drives you all the way to the end, disconnect all PCM connectors and inspect for pushed-out pins and corrosion. Reconnect all PCM connectors and make sure they seat correctly, then verify whether the concern is still present. If the concern is gone, it may have been caused by a loose or corroded connector. If the concern is still present on that branch, the supported direction is PCM replacement and programming. Now work the EGR valve and airflow side of the P0401 diagnosis. With the ignition off, look for aftermarket accessories or performance modifications first. Then inspect the intake air path for blockage, loose clamps, cracked tubes, holes, and gasket issues. Check the crankcase ventilation and charge air cooler systems for leaks or restrictions. Also look over the exhaust for obstruction, blockage, leaks, or soot trails. If you find a concern here, repair it, clear the PCM codes, and repeat the self-test. If the visual checks are clean, move into the EGR valve electrical checks. With the ignition on, monitor the EGR VP PID while working the harness in small sections from the EGR valve back toward the PCM. You are looking for the voltage to stay between 0.49 to 1.25 volts without spikes. If it does not stay in range, repair the harness concern, clear the codes, and repeat the self-test. Next, with the ignition off, disconnect the EGR valve connector, turn the ignition back on, and measure between C1389 pin 5 and C1389 pin 1. The reference voltage should be between 4.5 volts and 5.5 volts. If that is not in range, stop this EGR path and diagnose the reference voltage fault first. Do not guess past a bad reference circuit. With the ignition off and the PCM E connector disconnected, check the 3 EGR valve circuits between the EGR valve connector and the PCM connector. The resistance should be less than 5 ohms on each circuit. Then check those same EGR valve harness circuits for shorts to ground. Resistance should be greater than 10,000 ohms. With the ignition on, check for a short to voltage on those circuits. Any voltage present points you toward repairing that short. Finally, with the ignition off, check whether the EGR VCH and EGR VCL circuits are shorted together. That resistance should also be greater than 10,000 ohms. Any failed open or short test gets repaired before you continue. Then clear the PCM codes and repeat the self-test. Next, measure the internal resistance of the EGR valve control motor on the component side between C1389 pin 6 and C1389 pin 2. At the same time, record the MAF-LRN idle and MAF-LRN idle values. The motor resistance should be between 1 and 900 ohms. If it is outside that range, the supported direction is to install a new EGR valve, perform the required reset and clear actions, then repeat the self-test. If it is in range on a P0401 path, continue into the branch the test gives you, which can include the cooler bypass checks and the remaining EGR response checks. When the path calls for EGR position comparison, reconnect the EGR valve connector and PCME connector with the ignition off, then turn the ignition on. Monitor EGR VP while controlling EGR VP DES from the minimum to the maximum commanded value, and compare the PID to the EGR valve position sensor table. At 0%, the table shows 0.92 volts to 1.07 volts. At 65%, it shows 3.14 volts to 3.23 volts. Then monitor EGR AACT while controlling EGR VPDES. Decrease the commanded duty cycle to minimum, step it from minimum to maximum and back to minimum, and record the valve position. The EGR valve position PID should stay within 15% of the commanded PID value at all increments. A failed position match supports installing a new EGR valve, doing the reset actions, clearing the codes, and repeating the self-test. Next, with the ignition on, compare baro and EBP. EBP should be within 7.5 kPa, 1.09 psi, of the baro PID reading. If it is not, the supported direction is to install a new exhaust pressure sensor, clear the PCM codes, and repeat the self-test. For the airflow baseline, verify EOT is greater than 60 degrees Celsius, 140 Fahrenheit. Start the engine. Monitor EOT and MAF. Command VGTDC-MAMD to 100%. Increase RPM DSD to 1800 RPM. Control EGR VPDES and decrease commanded EGR duty cycle to 0%. The MAF PID should be greater than 0.08 kg per second, 80 grams per second at sea level, or 0.058 kg per second, 58 grams per second, at 10,000 feet above sea level. For the next airflow check, again verify EOT is greater than 60 degrees Celsius, 140 degrees Fahrenheit. Start the engine, monitor EOT and MAF. Command VGTDC command to 100%, increase RPM DSD to 1800 RPM, and command EGR VPDES to 40%. The MAF PID should be greater than 0.035 kilograms per second, 35 grams per second at sea level, or 0.021 kilograms per second, 21 grams per second, at 10,000 feet above sea level. Then run the bypass effect check. Monitor EOT, EGRTC, and MAF. Keep VGTDC command at 100%, raise RPM DSD to approximately 1800 RPM, command EGR VPDES to 40%, command EGR CBV on, wait 5 seconds, and command EGR CBV off while watching MAF and EGRTC. The passing result is a MAF increase by less than 0.005 kilograms per second, 5 grams second, and an EGRTC decrease by more than 25 degrees Celsius, 45.83 degrees Fahrenheit. If this bypass effect check does not pass, move into the cooler bypass diagnostic path instead of guessing. For the F-Series Superduty flow check, verify EOT is greater than 60 degrees Celsius, 140 degrees Fahrenheit. Start the engine and monitor ECT1, EOT, and MAF. Command TPDSD to 0% and command VGTDCMD to 60%. Decrease commanded EGR VPDES to minimum, then monitor and record MAF LRN idle and MAF LRN idle. Next, with ERT still greater than 60 degrees Celsius, 140 degrees Fahrenheit, command TPDSD to 0% and EGRTP CMD to 0%. Command VGTDCMD to 60%, increase RPM DSD to 1500 RPM. Command the EGR PID to 45%, and again monitor and record the learned MAF values. The decision here is whether MAF KG/SAS or G/SAS decreases when the EGR valve is commanded open. If it does not decrease, the supported direction is to install a new EGR valve, perform the specified reset functions, clear the PCM codes, and repeat the self-test. If the flow response passes, run the final cooler bypass response check. Verify EOT is greater than 60 Celsius, 140 degrees Fahrenheit. Start the engine and monitor ECT1, EOT, EGRTC, and MAF. Command TPDSD or EGRTP-CMD to 0%, command VGTDC-CMD to 60%, increase RPM DSD to approximately 1500 RPM, command EGR VPDES to approximately 60%, then command EGR CBV to 100%. Wait 5 seconds, command EGR CBV to 0%, and watch MAF and EGRTC. On this Super Duty pickup, the expected result is a MAF PID increase by less than 0.014 kilograms per second, 14 grams per second, and the EGRTC PID decrease by more than 28 degrees Celsius, 50 degrees Fahrenheit. If that doesn't pass, go back through the cooler bypass diagnostic path. If it does pass, disconnect all PCM connectors and the EGR valve connector. Inspect for pushed-out pins and corrosion. Reconnect everything so it seats correctly, and verify whether the concern is still present, while recording math LRN idle and math LRN A ideal. If the concern is gone, it may have been a loose or corroded connector. If it remains, the supported direction is to install a new EGR valve, perform the reset functions, clear the PCM codes, and repeat the self-test. Keep verification separate from testing. After any repair, clear the PCM DTCs and repeat the self-test. If the truck was in derate or had a system warning message, it may need to be driven until the message clears from the cluster. The key with P0401 is to prove airflow, EGR valve control, wiring integrity, and cooler bypass operation in order. Do not skip straight to parts. For more diagnostic training, visit stepdiagnostics.com.